Hello, welcome to another episode of CHP Tutorials. We're looking at management information systems today. We're looking at the fifth chapter. So in today's video, we'll be decoding the slides, right? So the fifth chapter is titled IT Infrastructure and Emerging Technologies, right? So how will we talk about this? Now the objectives for this chapter is for us to know what IT infrastructure is and what are the stages and drivers of the IT infrastructure evolution, right? How did it begin and how far has it come, right? That's what the evolution is talking about. Also look at the components of IT infrastructure, the current trends in computer hardware platforms and software platforms as well. And lastly, we'll be looking at the challenges of managing IT infrastructure and the solutions available to management. Let's begin. Alright, so when we talk about IT infrastructure, what is it exactly? So IT infrastructure is a set of physical devices and software required to operate an enterprise, right? That's plain enough, right? So the physical devices and software. So pay attention to physical devices, physical, and then the software required to operate an enterprise. So that's IT infrastructure, the physical hardware, and then the software required to operate an enterprise. Very well. So we can also say that IT infrastructure is a set of firm-wide services, right? It's a set of firm-wide, right, across the whole firm or across the whole organization. Services which include computing platforms which provide computing services, also telecommunications services, data management services, application software services, physical facilities management services, IT management, education, and other services. Very well. Now, you can also speak of it in terms of saying that it is a service platform perspective, right? So it's a more accurate view of the value of investment, right? So that's what the service platform perspective of IT infrastructure talks about. It's saying that is the accurate view of the value of investment, right? So the value of the investment that you are making. That's what IT infrastructure is from the service platform perspective, right? So here we are looking at the connection between the firm, IT infrastructure, and business capabilities, right? So we have a diagram here. That's figure 1.5, figure 5.1. The services a firm is capable of providing to its customers, suppliers, and employees are a direct function of its IT infrastructure, right? So saying that the services as a firm, an organization, the services that you are capable of providing to your customers, your suppliers, and employees, basically to your stakeholders, is a direct function of your IT infrastructure. So your IT infrastructure is what to use to perform those services, right? So it's a direct function. So your IT infrastructure allows you, determines your capabilities. So the capabilities of your IT infrastructure are the capabilities of your firm's services, like the services that your firm can offer. It's your IT infrastructure that will determine what you can do for your stakeholders, right? Ideally, this infrastructure should support the firm's business and information systems strategy. New information technologies have a powerful impact on business and IT strategies, as well as the services that can be provided to customers, right? So it's basically in the best interest of a firm to ensure that they are upgrading or enhancing their IT infrastructure, because the more capable your IT infrastructure, the more services your firm will be capable of offering to your stakeholders, your customers, your suppliers, etc. Right? So this is a diagram. You have your business strategy, your IT strategy, your information technology, right? So these arrows are just showing us that they are all linked, right? Business strategy is linked to information technology. Information technology is linked to your IT strategy. Your IT strategy is linked to your business strategy, right? And all goes into your IT services and infrastructure, which eventually translates to what customer services. I think that's customer services, supplier services, then enterprise services. Exactly, right? So if you look at it from in a reverse manner, you break down your customer services, your supplier services, and then your enterprise services can be broken down into what IT services and your infrastructure, or your IT services and your IT infrastructure, which is then broken down into what your IT strategy, your business strategy, then your information technology, which, as I said earlier, are all linked to each other, right, via these arrows. So moving on, so that's a connection between the firm IT infrastructure and business capabilities. Well, now here look at the evolution of IT infrastructure, right? Where did it start from and where is it at currently? Looking at that, we see that in the beginning, the general purpose mainframe and mini computer era, right? So that's what began the IT infrastructure. The general purpose mainframe and mini computer era. That was between 1959 to present. In 1958, IBM, that's an international business machine. So IBM first mainframes were introduced in 1958. But before that, in 1965, less expensive DEC mini computers were introduced, right? So the DEC mini computers came before the IBM mainframes, right? So from this point, so it's a general purpose mainframe and mini computer era, right? That's 1959 to present. That's just stipulating or making the fact that such computers are still around. Then have the personal computer era. That's 1981 to present, and that has to do with the introduction of the IBM PC, right? PC means personal computer. Now the proliferation in 80s, 90s, the 80s and the 90s resulted in a growth of personal software, right? So proliferation just means production, mass production, right, or mass productivity. So that means that personal computers became abundant in society. More people were using it, and as to that, it led to the growth of personal software. So these companies, these programmers started developing more softwares that could be used on a personal computer. So moving from the personal computer era, we go to the client server era, right? That was from 1983 to present. Now desktop client network. So this is just giving a description that with the client server era, we had desktop clients network to servers with processing work split between clients and servers, right? So the processing work, processing data. That's saying processing the function or the role of processing was split between the clients and the servers. Now in the client server era, network may be two-tiered or multi-tiered, n-tiered. Now there are various types of servers. There's a network, there's application, and there's a web, right? Well, moving on. So from the client server era, we come to the enterprise computing era, right? So with that, the enterprise computing era, that was 1992 to present, and with that one, you move toward integrating disparate networks, applications using internet standards, and enterprise applications. So enterprise computing era, and that era was from 1992 to present, and that was characterized by what? The move towards integrating disparate networks. So separate networks became integrated with enterprise computing in the enterprise computing era, and applications were now using the internet standards and so applications using internet standards and enterprise applications, right? Then now we have the cloud and mobile computing. So from the enterprise computing era, that was from 1992 to present. We move on to the cloud and mobile computing. That's 2000 to present. That involves cloud computing, computing power and software applications supplied over the internet or network. That's the fastest growing form of computing, right? The fastest growing form of computing. So cloud and mobile computing, 2000 to present. You have cloud computing. So 2000. So cloud and mobile computing started in 2000 to present. You have cloud computing, which involve computing power and software applications supplied over the internet or other network, right? And again, that was the fastest form of computing. Hope that's clear. Right, so let's just recap it all. So the first was the general mainframe and mini computer. From the mainframe and mini computer, we moved to personal computer era. That was from 1981 to present. Then from personal computer, we come to client server era. Moving on, where you have the enterprise computing era. Then cloud and mobile computing. Well, and that was the end of it, right? So that deals with evolution of IT infrastructure, right? Remember, there is a hardware and software in business, basically. That's IT infrastructure. Right, so now looking at the technology drivers of infrastructure evolution, right? So when you say technology drivers, what are some of the things that cause growth in the evolution of infrastructure, or what are the things that brought about progress in the evolution of the IT infrastructure? We'll look at Moore's law and microprocessing power, right? Now, Moore's law states that computer power doubles every 18 months. That's Moore's law. It says that computer power doubles every 18 months. Nanotechnology, that's speaking to the microprocessing power. So nanotechnology, right? It shrinks the size of transistors to size comparable to size of a virus. So very, very small. Makes basically nanotechnology helps shrink the size of transistors very small. So that's Moore's law. So computing power doubles every 18 months. And the microprocessing power is saying that with nanotechnology, transistors were able to be shrunk to the size of a virus. Now, law of mass digital storage. That law says that the amount of data being stored each year doubles, right? So the law of mass digital storage says that the amount of data being stored each year doubles. So Moore's law was computing power doubles every 18 months. Law of mass digital storage is that amount of data being stored each year doubles. Well, so these are two drivers and technology drivers of the infrastructure evolution. That's 1, 2. Now we look at Metcalfe's law and network economics, right? Metcalfe's law and network economics. So Metcalfe's law is saying that the value or power of a network grows exponentially as a function of the number of network members, right? So the value or power of a network, right? You have a network. Now the power of the network grows exponentially as a function of the number of network members. So you're saying that as the network members increase, the value or power of the network also increases, right? Now when you say exponential, you have arithmetic progression, right? And that's something like this. You have this. So it's like stairs, it's arithmetic. The common difference is set, right? But when you say something is increasing exponentially very quickly, right? Exactly. So it's saying that the value or power of a network grows exponentially as a function of the number of network members. So, very well. Now, as network members increase, more people want to use it. Demand for network access increases, right? So then, as network members increase, it means that what more people want to use it. So now access. So the demand for access for the network access is what increases, not necessarily the network access itself, right? That's where network economics comes in, right? Economics is the study of using scarce resources and wisely, right? So that's three, right? So there, let me check. Well, three laws were given. That the first was Moore's law, the 18 months, the law of mass digital storage. That's the second one, and the third is what Metcalfe's law and network economics. Declining communication costs and the internet. An estimated 3 billion people worldwide have internet access. As communication costs fall toward a very small number and approach zero, utilization of communication and computing facilities explodes. Right. So the declining communication cost and the internet being a technological driver of infrastructure evolution is simply saying that these 3 billion people worldwide have internet access. Meaning an estimated 3 billion people have internet access. That means that it's worldwide. Many people have access to it, and communication costs are becoming low, approaching zero. And due to that, many people are now using communication and computing facilities, right? So that's also one of the things that drives the evolution of infrastructure. So that was the fourth one. So this is going to be the fifth. We have standards and networks, right? So specifications that establish the compatibility of products and ability to communicate in the network unleash powerful economies of scale and result in price declines as manufacturers focus on the products built to a single standard, right? So technology standards. That's talking about the specifications that establish the compatibility of products and ability to communicate in a network. So the specifications, right? The design that lay the ground for products and the ability to communicate in a network to be compatible, right? Now, technology standards also unleash powerful economies of scale and result in price declines, price reduce, as manufacturers focus on the products built to a single standard, right? Well, right. Remember that we are all, as we are speaking, or management information systems is tied to the organization, right? So products here shouldn't really confuse anyone. We are talking about using IT infrastructure in a firm, right? So technology standards, we are saying that the specifications establish the compatibility of products, right? And the ability to communicate in the network. So the internet establishes the design for products, and this design is compatible because it also brings with it the ability to communicate in the network. So the organization is communicating with each other, with their suppliers. That's how come their products are compatible with market needs. That's what this. There's a deeper meaning, and you just have to relate it to an organization, right? Exactly. So having these technological standards also unleash powerful economies of scale, right? Economies of scale are the advantages that a firm enjoys when their production increases. As the production increases, right? More production, more money. And due to these powerful economies of scale, price drops because manufacturers focus on a product built to a single standard, right? So that's it. So that was the fifth point. So there are 5 points in all for the technology drivers of, of the infrastructure evolution. The first was Moore's law, microprocessing power, law of mass digital storage, Metcalfe's law, and network economics. Declining communication cost, that was the fourth one. And the fifth is what? Standards and network effects. So these are the five drivers of infrastructure evolution. Very well. Moving on, now we talk about the components, right? The components. Now, IT infrastructure has seven main components. Seven main components. One is computer hardware platforms. The second is operating system platforms. The third is enterprise software applications. We have data management and storage. Also, here we have networking or telecommunications platforms, internet platforms, and then consulting system integration services, right? Now, I want to take a look at each of these seven components, right? But remember that there are seven main components, and these are them, right? So, computer hardware platforms, that was the first. Then here we have client machines, network PCs, laptops, mobile computing, like, that's why you have the smartphones and tablets. With the servers, we have the blade servers, which has to do with ultra thin computers stored in racks, right? So servers are simply ultra thin, like very thin computers stored in racks, right? If we say ultra thin, it doesn't mean it's like this. Just think of a normal computer and imagine it being right. So blade servers are blade servers. So ultra thin computers. So this blade servers is speaking to a specific, servers used in organizations, right? But we have servers that are not, right? Anyway, so this is actually ultra thin computers stored in racks. Exactly. Now there's the mainframes, IBM mainframe equivalent to thousands of blade servers, right? So here it says that an IBM mainframe is equivalent to thousands of blade servers. So here you have top chip producers. That's the microchip, the microprocessor. Anytime you open your laptop, look here on the laptop, you see what? Intel Core i3, the Core i3, i5, i7, Intel Pentium, AMD, that's another producer. Right? These are all, that's the specs of your chip, your microprocessor. So that's what computer hardware platforms speaks to: client machines, servers, mainframes, top chip producers, Intel, AMD. Right. Now, one second. Yeah. So that operating system platforms here. So the operating systems, the server level is 65% run Unix or Linux, 35% run Windows. So with the operating systems at the server level, 65% is run by Unix or Linux, right? And then 35% is run by Windows. At the client level, 90% run Microsoft Windows. That's Windows 8, Windows 7, etc. Then the mobile or multi-touch, screen touch. That's Android or iOS, right? Now I have cloud computing, Google Chrome's OS, Google Chrome's operating system. Moving on now, we have what? Enterprise software applications. Here we have enterprise application providers like SAP and Oracle. So those are all enterprise applications. Now middleware providers, middleware providers are IBM, Oracle. Then there is data management and storage, right? So the database software, you have IBM, that's DB2. I think that's database two. There's Oracle, there's Microsoft SQL, SQL. That's also a language. That's structured query language server. Then Sybase, that's the adaptive server enterprise. My SQL or my SQL. Right, so that's the database software. We also have the physical data storage. That's EMC Corp. Large scale systems, Seagate, Western Digital. Then there is the storage area networks, SANs, and they connect multiple storage devices on dedicated network. Right, so the SANs, the storage area networks, connect multiple storage devices on a dedicated network. Very well. So that's for the data management and storage component of the IT infrastructure. So for the networking or telecommunications platforms, so telecommunications services, there's telecommunications, cable, telephone company charges for online, for voice telecommunications, right? Telecommunications, cable, telephone company. So we're saying that telecommunications company, cable company, and telephone company charges for voice lines and internet access. So there you have, I think these are companies, right? There's AT&T, and there's Verizon. There's the network operating systems. You have the Windows Server, Linux, and the Unix. So that's the network operating system. Windows Server, Linux, and Unix. Now, network hardware providers include Cisco, Alcatel, Lucent, Juniper Networks, right? So these are networking or telecommunications platforms that speaks to the IT infrastructure company. So that's for the networking or telecommunications platforms component of the IT infrastructure. Now you have internet platforms. Here you have what's hardware, software, management services to support company websites, including web hosting services, intranets, extranets. There is the internet hardware server market. IBM, Dell, Sun, Oracle, and there's also HP. You have web development tools or sites like Microsoft, that's Visual Studio and .NET. You have Oracle Sun, Java, Adobe Real Network. So these are that I've just mentioned: Microsoft, Visual Studio and .NET, the Oracle Sun, Java, Adobe Real Networks. Like these are examples of web development tools or suites, as in Microsoft suite, right? Yeah. So there's consulting and system integration services, right? And we have even large firms. Once again, so for this component, consulting and system integration services, consultation and system integration services. We have even large firms do not have resources for full range of support for new complex infrastructure, right? Leading consulting firms like Accenture, IBM Global Services, HP, Infosys, Wipro Technologies, right? So these are leading consulting firms, right? Now, software integration, with that one, it has to do with ensuring new infrastructure works with legacy systems, right? Now, exactly. So legacy systems here refer to older TPS, that's transaction processing systems created for mainframes that would be too costly to replace or redesign. Right, so when you hear legacy systems, it's just referring to other systems or other transaction processing systems created for mainframes that would be too costly to replace or redesign. Right. So when you say software integration, you are ensuring new infrastructure works with legacy systems. Right. Make sure that the new infrastructure that we are making is working with legacy systems, older TPS. And yes, it's just making a statement that even large firms do not have the resources for full range of support for new complex infrastructure, right? So now look at the current trends in hardware platforms. The mobile digital platform. So current trends in hardware platforms, they have the mobile digital platform. They have smartphones, right? They have iPhone, Android, and BlackBerry. Well, BlackBerry is not in the system anymore, so that's not really a trend now. So for under the smartphone, there's data transmission, web surfing, email, and internet messaging. IM. Then the netbooks. That's small, lightweight notebooks optimized for wireless communication and call tasks. You have the tablets, iPad, network e-readers. You have Kindle and Nook. Then wearable devices like smartwatches and smart glasses. Right? These are the current trends in the hardware platforms. Now, one thing is that bring your own device. That's BYOD. Allowing employees to use personal mobile devices in the workplace. That's cool. Now, consumerization of IT. Consuming IT. Don't mind them. Consuming IT. That's the meaning of that word. So, new information technology emerges in consumer markets first and spreads to business organizations. Right? Forces. So this consumption of IT forces businesses and IT departments to rethink how IT equipment and services are acquired and managed. There's quantum computing, which uses quantum physics to represent and operate on data. There are dramatic increases in computing speed. Right? That's due to with quantum computing, you have dramatic increases in computing speed. So you have what virtualization, which allows single physical resource to act as multiple resources. Virtualization allows single physical resource, right? A single physical resource to act as multiple resources, i.e., run multiple instances of operating systems, right? So let's say you have one physical resource, maybe one physical component running multiple OS here is standing for operating systems, right? Now it reduces hardware and power expenditures. So with that one, you don't need too many hardware components. You could just, with the help of virtualization, you can run multiple operating systems on one device. So it reduces your expenditures. Now, and your power consumption as well. Now, virtualization also facilitates hardware centralization. Centralization. So, cloud computing is also a trend. Now, with that one, it comes to the on-demand utility, right? The on-demand use of computing services obtained over a network. So, cloud computing is looking into this today. You have infrastructure as a service, platform as a service, software as a service. Right now, cloud can be public or private. It allows companies to minimize IT investments, drawbacks, the concerns of security, reliability. Now, hybrid cloud computing model, right? So, combination of two things basically. So, say this cloud computing platform, you have cloud computing. These are the servers, laptops, iPhones, tablet computers, and then desktops. Now these are the platform services, application services. So let's read this. In cloud computing, hardware and software capabilities are a pool of virtualized resources provided over a network, often the internet. Businesses and employees have access to applications and IT infrastructure anywhere, at any time, and on any device. Right. So that's the benefit of cloud computing, having access to applications and IT infrastructure anywhere, at any time, and on any device. Right. So these are the you have sellers, have laptops, iPhone, tablets, desktops. Right. So these are the devices, and this is what you have access to: platform services, application services, and infrastructure services, right? Or because of cloud computing. Very well. So this is a interactive session. Seeing I'm only one, we skip it, right? So current trends in hardware platforms. So we are still continuing that, right? Wait a minute. Yeah. So green computing. What's green IT? So green computing or green IT practices and tech that has to do with the practices and technologies for manufacturing, using, disposing of computing and networking hardware. Right, so the practices and technologies. So the practices and technologies that are used to manufacture, used that are used to manufacture, and also used to use and also dispose of computing and networking hardware. So that's green computing. Is so that it reduces the power consumption, reducing power consumption. So in green computing, reducing power consumption is a high priority, and IT responsible for 2% US power demand. Right, so many technology is responsible for 2% of the United States power demand. That's green computing, right? Reducing power consumption, and it involves the practices and technologies for manufacturing, using and disposing of computing and networking hardware. Now, I asked you it, and we also have high performance power saving processors. So that's also a current trend, right? It's booming, right? So high performance and power saving processors is a fact, a trend. We have multi-core processors, power efficient microprocessors. Very well. So let's look at the software platforms, the trends in the software platforms. We have open source software that's produced by a community of programmers, free and modifiable by user. So with the open source software, with the software platforms, one trend is the open source software. Right. So with the open source software is produced by a community of programmers, free, mobile, and modifiable, free and modifiable by the user, right? So that whoever uses it can modify it, and it's free. You don't have to buy it. Examples are Apache web browser, Mozilla Firefox browser, and OpenOffice. Now with Linux, we have open source operating systems used in high performance computing, used in mobile set devices, local area networks, web servers, and Android operating systems. Right, so that's a trend, right? With Linux, it's an open source operating system, and it's used in high performance computing, also used in mobile devices, LANs, web servers, and Android operating systems. Now in the software for the web, now you have Java, HTML, HTML5, you have Ruby and Python, right? These are programming languages, right? So it's useful to learn them if you want to get into coding and stuff. You have object-oriented programming language, that's the Java operating system, processor independent. HTML5 is the latest evolution. HTML5 is the latest evolution. Now it embeds media, animation, and supports cross-platform apps and offline data, Ruby and Python. Now the web services, software components that exchange information using web standards and languages. XML, extensible markup language, more powerful and flexible than HTML. So the current trend in web services are these, right? XML, that's extensible markup language. That's what the XML means, extensible markup language. And that's more powerful and flexible, right, compared to HTML. And tagging allows computers to process data automatically. And there's the SOA, that's a service-oriented architecture. That's a set of self-contained services that communicate with one another to create a working software application. So that's what the SOA talks about, the service-oriented architecture, right? That's something that's going on currently in software platforms, and that's the set of self-contained services, right, that communicate with one another to create a working software application. Now, software developers reuse these services in other combinations to assemble other applications as needed. So, software developers reuse these services in other combinations to assemble other applications as needed. Right. So, an example is an invoice service to serve whole firm for calculating and sending printed invoices. Right. So, whereas that this invoice service is invoicing the printing of invoices. That's what it means by the self-contained services that communicate with one another to get a working software application. Right, and software developers are using these services again in other combinations to assemble other applications as needed. So that's the invoice service, printing invoice, sending printed invoices. That's an example of that. That's the service-oriented architecture. Now, Dollar Rent a Car, that uses web services to link online booking system with Southwest Airlines website. And that's a dollar rent. So Dollar Rent a Car is also another trend in the software architecture, in the software platforms of IT infrastructure. And there's a software outsourcing and cloud services, right? So that's another trend. There are 3 external sources for software. There are software packages and enterprise software. There's a software outsourcing, that's contracting outside firms to develop your software. And the cloud-based software services, software as a service, access with web browser over the internet. There's also service level agreements, SLAs, with a formal agreement with service providers. So these are the 3 options: software packages and enterprise software that you can go and buy. You can go and buy, it's already made, or you can outsource the software and have another firm develop it for you, or you can use the cloud-based software services. Yeah. So with the software outsourcing and cloud services trend, there's also mashups. That's the combinations of 2 or more online applications, such as combining mapping software, Google Maps, with local content. There's also the apps, small pieces of software that run on the internet, on your computer or on your mobile device. Refer commonly to mobile applications, that's iPhone and Android, and they tie the user to the platform. So the apps that we use on our phone every day is also a trending softwares, outsourcing and cloud services. So what are the challenges? So the challenges. So one challenge is dealing with platform and infrastructure change. So as firms shrink or grow, IT needs to be flexible and scalable. Right? So that's a challenge. So with the scalability, the ability to expand to serve larger number of users, right? Now for mobile computing and cloud computing, new policies and procedures for managing these platforms. Now contractual agreements with firms running clouds and distribution distributing software required. So these are the challenges, right? So dealing with platform and infrastructure change, right? As firms shrink or grow, IT needs to be flexible and scalable. That's before you said that, right? So these are just elaborations, right? So that's a challenge dealing with with platform and infrastructure change. So management and governance, right? Who controls IT infrastructure? How should IT department be organized? Should it be centralized or should it be decentralized? Right? So should the IT department be centralized or decentralized? How are costs allocated between divisions and departments? Right? So this is like man accounting. So everything is related, right? Now, so that's a challenge. So the first was what? Dealing with the platform and infrastructure change, management and governance. It's another challenge. Now, making wise infrastructure investments. Right, amount to spend on IT is complex. It's a complex question. Right, should you rent? Should you buy? Or cloud computing? What about outsourcing? And the total cost of ownership (TCO) model. This one analyzes direct and indirect cost. Hardware software accounts for only about 20% of TOC. That's the total cost of ownership, right? Now other costs are installation, training, support, maintenance, infrastructure, downtime, space, and energy. So these are the things that you need to consider, when making infrastructure investments in IT. Now the TCO can be reduced when you use cloud services. There's greater centralization and standardization of hardware and software resources. Exactly. So the challenge of managing IT. So the competitive forces model for IT infrastructure investment. So this is more like a solution, right? So market demand for so it's the same, Porter's 5 forces. It keeps replying many courses. Right. So here you have. I think we spoke about this one of the weeks. I think it was week 3 or so. So you can check that. You can check out that video too. We talk about the competitive forces model. You have the market demand for firm services, the firm's business strategy, firm's IT strategy, infrastructure and cost. Then the IT assessment, competitor firm services, and the competitor firm IT infrastructure investment. So these ones they are detailed or they are personalized. They are internalized by information technology, but basically it's speaking to the same thing. Well, this is how you manage them. So, this is the end of the slide. So these are the solutions to the management challenges, right? So you can have so one is market demand for firm services. That's how you compete. Your business strategy too is a factor. Your IT strategy, your infrastructure, and your cost. Information technology assessment. Competitor firm services. Competitor firm IT infrastructure investment. So these are like guidelines for you to compete or even out compete. That's all for this video. Thank you very much for watching. Please don't forget to like and subscribe.